This lesson is going to look at cubes and cube roots. It is very similar to the lesson that we looked at squares and square root. So a cube is also a special type of exponent, whereas a square was when the exponent was specifically a 2, a cube is where the exponent is a 3. So if we're looking at this specific example, we could be saying that this is out loud as 4 to the third power or 4 cubed. So what it means, again, is the same thing as a square, except it means to multiply the base, or the 4, by itself, this time 3 times. So 4 times 4 times 4, which would be equal to 64. So this, again, list in blue is another very important thing to have. This only goes to the first 10 perfect cubes, because once you notice that towards the end of that list, those numbers are getting very large very quickly. So those are the first 10 numbers cubed. So for example, 1 cubed is 1 times 1 times 1, which is equal to 1. 2 cubed is 2 times 2 times 2, which is equal to 8, and so on all the way through 10. What cubes are used for is for three-dimensional figures. So let's take a look at this prism. Or a cube, we know that all sides are squares, and we know a square, all sides are the same. So every side of that cube should be 7 centimeters. So when you find volume of a prism, the formula itself is volume equals length times width times height. We know that each edge or each side of that cube, though, however, is the same. So we could also say that the formula is the edge cubed, or the edge to the third power. So I could say that volume is equal to 7 to the third power, or 7 cubed, which would mean 7 times 7 times 7. Which would, if you look at your list, give you 343. And then our units, when we're talking about volume, we always have our units are centimeters, but in this case we're talking about volume, so we have a 3 as our exponent. So our answer is 343 centimeters cubed times 2. Let's take a look at this time if we know the volume and we want to find out how long each edge or each side is. So just like before, we have to go backwards. So we want to think about what number multiplied by itself 3 times is going to give me the volume, which was 8. I know that it is 2 because is 4, and 4 times 2 is 8. So I know that the volume being 8 centimeters cubed makes it a length of each edge is 2 centimeters. Notice it is just centimeters. It is not centimeters cubed. The only thing that ever should have a cube on it when you're done in your units is if you're looking at something of volume. So what you're really looking at here is a cube root. Notice this time it has an index. It has a number here inside the square root, or inside the root symbol, the radical symbol. That's why we know it's a cube root, not a square root. The square root doesn't necessarily put the 2 there, but the cube root has to put the 3 there. So again, that's asking you, because if squares are the opposites of square roots, then cubes are the opposite of cube roots, right? So it's asking you what number times itself 3 times is going to give me 27. Well, we know that's 3 because 3 times 3 times 3, or 3 cubed, is 27. So the cube root of 27 is 3. So let's take a look at a problem similar to the one we just did. This time we know the volume is 125 centimeters cubed. What is the length of each edge? So what we're thinking, we have to think that we're looking at the cube root of 125, or basically what number times itself 3 times, because the cube root is going to give me 125. And we should recognize that that's 5, because 5 times 5 times 5, or 5 cubed, is equal to 125. So the length of each edge is 5 centimeters. And again, we're looking at length, we're not looking at volume, so it's just centimeters. So let's take a look at something a little more complicated that relates volume and area together. So this time, we know that the cube has a volume of 64 cubic centimeters. We want to know what its surface area is. Surface area is a special type of area. Surface area is the area of all sides of the cube. For example, if you were to take a wooden block in the shape of a cube and you wanted to paint it, surface area would be how many units of paint that you would need in order to paint every single side. So the first thing we need to do, there's a couple of steps in this. Step 1 is we need to find the length of one edge. So we just did something similar to that. We want to find the length of an edge. We know the volume. That's the cube root. So I want to take the cube root of 64. Or it's basically asking me what number times itself 3 times, because the cube root is going to give me 64. And that should be 4, because 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. Step 2 is you want to then find the area of one face. The area of one face, the face of a cube is a square. So remember, the area of a square was area equals side squared. So we have our side, which we just found here, was 4. So area is equal to 4 squared, which means that is 16, because 4 times 4 is 16. So the last step in this is here. How many faces does a cube have? A face is a geometric word for side. So how many sides does a cube have? If you think about a die or a dice, right? Dice have 6 sides. So I need to take my 16 and I need to multiply it by 6, because each face, each one of those 6 faces has an area of 16. So 6 times 6 gives me 36. Carry the 3. 6 times 1 is 6, plus 3 is 9. So the surface area is 96 centimeters squared.